Hey everyone, happy New Year. Welcome back, Azure Cosmos DB Live TV. Happy to be back after, I guess, about a month off. I guess we took most of December and I guess now almost the first half of January off, but we're back and ready to go and got a great show lined up for you with my friend Rodrigo Souza. How are you, sir?
I'm fine. How are you?
I'm good. You know, I think you were on like episode 2 or 3 on Python SDK. That's how long it's been
Yes.
since I've had you on here, or at least on a dedicated episode.
That was a good episode.
That was a good episode. You know, we just did async IO support for that, right? That was in December. So, hey, if you're Python SDK user, come download the latest on PyPy and check out all of our async IO support in our Python SDK. So more good stuff coming on Python, hopefully later this year. But I'm glad we got that in there. So let's not talk about Python. Let's talk about Azure Synapse Link. So this is the first time we've talked about Synapse Link on our show. And I wanted to, a couple things. I want you to talk about what it is and why and kind of the benefits of that. And then I know at Ignite, or later last year, we did a bunch of updates for this. So I know you wanted to share some of that because, frankly, some really cool stuff the team put together for that. So, yeah, where do you want to start? Can we just start at the beginning, I guess, and go from there?
Exactly. So let's go. We'll start with an overview of what is Synapse Link for Cosmos DB, and then I'm gonna explain the last updates we had. There will be a demo as well, and I will close with our roadmap, right? So many customers asking about what's next, what's coming. I will show what's in the pipeline for Synapse Link. So let's get started. What is Synapse Link? So let's say this is your regular Azure Cosmos DB container. And let's say it's row-oriented, meaning that every single document that you insert in your Cosmos DB, it will be stored in a row in a data file, right? But now we are syncing, Synapse Link will sync your row-oriented data into an analytical format. It's a column store format, and this format is optimized for analytics.
Now, this is like a Parquet format, I think we're using, right? Something similar to that, or very close to that.
Exactly Parquet format.
Okay.
Right? And now, with this columnar format, customers using Synapse Analytics, both SQL serverless or Spark runtimes, can query this analytical format through our cloud-native HTAP connection, right? So the idea here is to optimize analytical workloads that people used to do on the transactional store. Now they have this alternative to use analytical store, right? Why? Because it was built for that. It was built for analytics. That's the nature of the columnar format. And with that, we can address workloads like machine learning, big data analytics, BI dashboards, and so on. Data exploration. Also, we are seeing customers using analytical store and Synapse Link for data engineering. So let's say they need to move Cosmos DB data somewhere else. Don't know, doesn't matter where. Another cloud, another service on Azure, doesn't matter. If you extract the data from transactional store, you have more costs and lower performance than if you use analytical store. So that's a good example of how customers are using our product.
Oh, interesting. So we're and just to point out, when we're ETLing this data from row store into this column store format, this Parquet format, that's not costing them anything from a throughput or RU perspective, right? So as they're ingesting data, and this is kind of the problem we were solving, right? Is people were trying to run analytical queries on top of the transactional store and not getting awesome performance because, frankly, it's a row store. It's like you said in your slide there. This thing is it's optimized for like high volume throughput and writes and stuff like that, right? Not meant for doing long running analytical queries that can take minutes or many minutes. So we get it out of there, put it into this Parquet format, use an appropriate analytical compute layer like Spark or SQL Serverless, run your queries. And then I guess you get all of the benefits from being in Synapse, right? So that's all the machine learning and dashboards and all that stuff. But then that other point, that's interesting. So it's in Spark, or you can connect to Spark, so you could query it and then potentially stream that to something else. Then is that what you're kind of saying? You could use like Spark streaming.
Exactly. So Synapse Spark has built-in many connectors, SDKs. Yeah. It's really easy to integrate this data somewhere else. As an example, we have Azure Machine Learning SDK. It's built-in Spark, Azure Synapse Spark clusters, right? So it's built-in, it's already there. You don't need to do much to get it up and running. And talking about the benefits you mentioned, we use for this sync between transactional store and analytical store, we use 0 RUs, no costs. Performance is completely independent, right? This sync won't compete with your transactional workloads to sync the data and create this analytical version, this columnar version of your data, right? Also, analytical store, since it's columnar, it has a natural compression of the data. We are seeing up to 90% of compression if we compare with transactional store. So it's way smaller.
Wow.
And it's cheaper. It has 10% of transactional store cost. So you are saving 90% of 90%, you know?
So customers that are like, say, using blob storage to do kind of like data archival could potentially use this, because if it's 10% of what our cost is, that's essentially equivalent to blob storage pricing.
Exactly. And we rely exactly on the same Azure storage that customers do. So we are just using the same pricing. Of course, not exactly. We have a different pricing policy, but at the end of the day, that's the same thing, right?
Yeah. I mean, that's, this would be a cheap, easy way to do basically your data archival if you wanted.
Exactly.
Within there. And then you could just TTL it off of the row store, and then it's always going to be available. And then, if you need to get access to it, sure, write a Spark query or a SQL Serverless query, and
that's a great point, because transactional store and analytical store, they both have independent TTLs.
Yeah.
So you can keep your transactional store data, I don't know, for a week, for a month, and the data in analytical store forever.
Yeah.
Right.
Yeah.
And there is more good news here. When you're using Synapse to read from analytical store, again, you're not using RUs. Again, so you're not paying to do your analytical queries.
Well, but you got to pay for the Spark or SQL Serverless compute, don't you, for those?
Exactly. You're going to use Synapse runtimes, and they have their own pricing, right?
Yeah.
But again, if you want to save money with RUs and Cosmos DB throughput, again, you have this, right, this benefit.
For sure, running these types of queries using Synapse is going to be dollar for dollar cheaper than trying to do the equivalent thing in Cosmos. I can tell you that right now, right? So,
and these Synapse runtimes, they are on demand.
Yep.
You can pause them, right? And if you do exactly what you mentioned before, if customers keep transactional store smaller than analytical store, they can again save with RUs, because they have, with less gigabytes, they will have less RUs, minimum RUs necessary for the workload, right?
Yep.
But
and they could even take and rewrite this data. I'm harping on all the stuff you could do, but like, say you TTL data off row store and you keep an analytical store, just write another little Spark streaming and just connect back to the row store, and you could write it back into another Cosmos container if you wanted to move it back into a hot store again, or you could write right back into the same container if you wanted. Even I mean, nothing's stopping you there either. So
exactly, we have customers doing things like that. Let's say another example for you. Today, Cosmos DB query language doesn't allow customers to do joins.
Yeah.
Right. But now with SQL serverless, you can do joins between different containers. And with Spark, you can do lots of massive aggregations. And maybe you want to save this data back to transactional store, to provide information to a mobile app that reads the last upload.
Yeah, I mean, lots of customers use Cosmos as a serving layer. So that's functionally what you're talking about is go and do all your heavy aggregations, analytics, and then just write it back using the Spark connector back into Cosmos, and then use that as a serving layer for whatever you're doing with that data, however you're
yes, in a new container with a different partition key, a partition key that is focused on this, probably this other serving layer, right? They have a different, they will benefit from a different partition key, right? So exactly.
Yeah. See, folks, there is no limits to what you can do with Synapse Link. This is why I wanted you on. It's more than just a way of being able to offload your analytics. You can, like we're describing, you can do literally anything, all kinds of stuff with this capability. Great stuff.
Also, we have this last comment here: generate near real-time insights. What is near real-time? So near real-time means that we'll sync your transactional data with analytical data every 2 minutes. The more data, the better. You may think, oh, I just uploaded one document. Okay, it will take 2 minutes. But if you're uploading a lot of data, it will be faster, right? Because we try to avoid fragmentation in analytical store. So the job, try to wait as much as possible to get a bigger chunk of data and create bigger columnar files in analytical store, right?
So is this like a polling mechanism? How does this work this every 2 minutes? Is that functionally what's happening? So it polls every 2 minutes and then pulls whatever's new or changed within the row store?
That's a very good point. New or change. Because usually columnar files, they are append only.
Yeah.
Ours, it supports all kinds of transactions, deletes, updates. So that's interesting. And we keep track, and customers will always see the last state, the last version of the data in an analytical store. Right.
Right. So it's not an op log, right? We're actually merging data back together again after it's deleted or updated or whatever within there, right? So so I'm guessing we've got something in the background, like a runner or something that's keeping doing hygiene or maintenance on the files, I guess, in the background there, kind of, right? So
exactly, we have a whole bunch of brand new technologies that keep the files with the last version of the data, right? And a couple of other interesting aspects here. It's fully self-managed, so customers don't need to worry about throughput, storage, downtime, things like that, right? So analytical store will always be there for your customers. You don't need to worry. There is no impact in your transactional workloads because it's fully isolated. Again, it won't use your RUs and it won't compete to read the same data because we use log store, right, to do this sync. We manage the schema inference. This is a huge challenge. Right?
Yeah, right. Because we're we don't have any schema enforcement. So let's talk about that.
Exactly. How do we convert? How do we represent semi-structured data in columnar format that is very structured, right? A couple of magics happen behind the scenes, and our documentation is very rich on what to expect expect from these conversions we do, from these automatic schema inference we do, you know. So, but this is a big challenge, and this challenge leads us for the first point for the first update I'm gonna mention. We have a new capability for SQL API, and I will talk about it in the next slide. But for now, we can say that customers don't need to worry to manage, oh, I created a new column, a new property in my schema here in Cosmos DB. It will be there automatically in Analytical Store, right? We have this native integration with Synapse runtimes, and Cosmos DB data is always available for analytics in any region, any Azure region. So what that means, let's say you have data, you have Cosmos DB data in East to West and West to West. You're going to have Analytical Store in both regions.
Oh, that's interesting and very cool as well.
So let's say you have the analytics department in the other side of the planet. Okay, just replicate the data there. There will be an Analytical Store there. And with that, we can avoid latency. We can keep the data close to the team, to the application, and so on.
So when I provision compute for doing my analytics, I'm provisioning it in a single region though, correct? Or is that also getting provisioned in every region?
No, when you are creating your Synapse workspace, you need to define a region. Yes.
Okay.
But that's a good point. From a Synapse workspace, right? If you don't say anything, it will try to read data from the primary region. But you can specify any other region where you have data replicated.
Okay, so that makes, okay, so I guess the namespace to the data is going to have a path that includes a region to where that data is located?
Yes, we accept this information, this option, and customers will read from any region they want.
Okay, that's good. I mean, I like that because I'm not paying for data egress, and if I'm doing analytic queries, those are going to be, I'm pulling terabytes of data probably. So I don't want to, I mean, egress doesn't cost a whole much, but when you're doing lots and lots of analytics and pulling terabytes of data every day, that does add up over a month. So that's a good thing. We're basically covering the costs for that egress, I guess, or well, I guess maybe not. I mean, we do charge, I guess, to replicate data for the egress. Yeah. So I guess that's happening. Exactly. What I guess I don't know is happening is are they paying, are customers paying again for the egress for Analytical Store when it's replicating?
If they are reading from a Synapse workspace that is not in the same region, they will pay. So does it replicate?
Does the ETL happens from the local region? So it's in region, the ETL.
Yes, exactly. In region, no problem.
Okay, so then the customers only pay for egress once through row store. They don't pay for it again on Analytical Store. Okay.
And we had a case when a customer had a really bad performance because their Power BI tenant was in another region. So it was a perfect storm. Data in, East to West, Synapse workspace in West to West, and the users were in India using Power BI tenant that was in India as well. So what we did was to add another region to the transactional store. Yeah. Automatically, they have data replicated to India as well, and performance went to terrible for great, right?
Yeah, because it's data locality, right? The closer you get your data, the lower the latency, right? It's just basic physics. Data can only move no faster than the speed of light, and often moves way slower than that on a WAN. So there you go.
And important, Power BI, when you're using Power BI Web, not the desktop version, of course, but Power BI Web, it has a region.
Yeah, okay.
It's somewhere. So customers should take care and double check where is their Power BI tenant and try to create Synapse workspace in the same region, try to have the data in the same region. So that's a very good best practice we have.
Yep, makes sense.
So talking about schema, this schema inference we have, what is new? What is new is that now we allow customers using SQL API accounts to enable full fidelity schema. So what that means? So schema inference is a property, is an account level property defined when you enable Synapse Link for that account. So when you enable Synapse Link for your Cosmos DB database account, we're going to create the required storage infrastructure behind the scenes. And that's the moment when you need to enable, to decide what is your schema inference type. Which schema inference type you want for your account. And that will be used for all containers in that account, right? And this is really important. This can be changed later. So until a couple of weeks ago, well-defined schema was the default option for SQL API, and full fidelity schema was the default option for MongoDB API. And customers couldn't change this option.
So can you define what well-defined schema means, and then what full fidelity schema means? Because I'm not clear on what's the difference, I guess.
Yes, that's a great question, and the best question is when the answer is in the next slide.
Oh, okay. I'm glad I could tee you up for next.
I'm going to give you a great example, and you understand what I'm saying. But important call-outs here is that now customers using SQL API can use full fidelity instead of well-defined. Using PowerShell or CLI, it's not in the portal yet. It will be there. And MongoDB is still using full fidelity. No change for now. But if we have a couple of customers asking for well-defined for Mongo, we may change that. But full fidelity for SQL was a common ask from our customers, and it's available now. So
I just want to let that sink in for folks. So we have support for MongoDB with Synapse Link. So if you're using MongoDB API, you could enable analytical store and provision SQL serverless and write T-SQL queries on top of your Mongo data.
Exactly.
Just let that sink in for a moment, folks. Writing SQL queries on top of Mongo data.
Doing joins, creating views, running
everything.
T-SQL start procedures, the whole thing.
Pretty awesome. Pretty awesome. Okay.
So let's see more about full fidelity. What full fidelity means? So it means more flexibility, but more coding. So I have two initial examples here, and the next slide will give you more details. But when you're using well-defined schema, the property will be a column in analytical store. The document property from transactional store will be one column there. So it'll be, let's say we have this container C, and I want all data where status equals to 1, right? So 1 here, it's a string, and that's well-defined. For full fidelity, let's say we have also documents where status is an integer. 1, but integer. So we're going to create one column for each data type you have. So it would be status dot string. We add this suffix to the column.
So is that why you would use full fidelity, is just to disambiguate where you've got properties that have multiple data types?
Yes, because in columnar files, you can have a column with multiple data types, like any table in a relational database. For a column can't have more than one data type, right? But in NoSQL database like Cosmos DB, you can do it. Right?
Sure.
So how to get rid of that? So for well-defined, you always have one column for one property. In full fidelity, we're going to have one column with a suffix as the data type for each data type of the property in the document. So let's see another example here, the next slide. But as you can see, more coding, right? Because if you
Yeah.
want all rows from C where status is 1, there is the one that is an integer and one is a string. So you need to do a little bit more coding, right? So again, let's see this example here where in ID1, let's say we have 2 documents in our container. ID1 status is an integer. ID2 status is a string, right? So in well-defined, the schema would be ID string and status an integer, right? And when status, what we do, the first document defines the schema of analytical store. So the first document in this example here, status is an integer. So when it is a string, it won't be represented. It will be null. Data won't be fully represented.
Yeah. You said the first document is used to infer the schema?
The first document defines the schema of analytical store.
So
in well-defined.
That's interesting. How does it handle scenarios where users are storing multiple different entities within the same container? Like, I'll give you an example. So I do a modeling session, and I show how you can take and have like a customer container with customer ID as the partition key, and then I can store within each logical partition one customer document where the ID and the partition key is the same, and then I can store all their orders within that same logical partition. So the entities are different. Like customer is a different schema than order.
No problem.
If I started writing that, or if that started getting ingested into Synapse, how is it going to handle?
No problem.
Really?
No problem. Because at some point you have a property in your document saying that it is a customer or another, correct?
Yeah, typically it's something called type or whatever like that, and then I have some constant value in there, like this is a customer document and this is because I need that when I'm reading data out of the container. If I'm not using type as a filter in my filter predicate, I need to inspect the value before I deserialize it into a class, right? Or I'll throw an exception.
Yeah, it'll be no problem because when it's type customer, all orders properties will be represented with null, and the opposite also happens. So at the end of the day, you're going to have all data there. The problem of well-defined is if for some customers the telephone number is an integer, and from other customers the same telephone number is a string. That's for well-defined is a problem, right? Okay. And what we do is to when the new document doesn't follow the initial schema, the initial data type, it will be represented with null. For full fidelity, no, we have it all. So we're gonna have in this small example here we have. So for the first document, there will be 3 columns, right? ID.string that is common for both documents, and 1 status column for each data type. So for the first document, it will be 1 for status integer and null because they don't have status.string, and the opposite happened for the second.
Got it.
Yeah.
Got it. Okay.
So all data, the difference at the end of the day, for well-defined, when you don't follow the initial data type, data won't be represented. For full fidelity, all data is represented with more columns. Right?
Got it. Okay. I understand now what the difference is between well-defined and full fidelity schema. Nice. I never really quite understood it fully, but yeah, it makes sense.
Yeah. So again, I'm going to do a quick demo, but again, this is only available with CLI or PowerShell. To create a SQL API account with full fidelity. It'll be in the portal soon.
Okay.
But not now. And we have something else that is not in the portal yet, another update that is now we have support. It's an Synapse Link for serverless accounts, right? Again, SQL API or MongoDB. And again, it's not in the portal yet, but you can do it. You can create these accounts. You can enable Synapse Link for serverless accounts using PowerShell or CLI, right?
Oh, got it. For Cosmos serverless.
Yes.
Okay.
And there is no limitations, no different restrictions. It's Synapse Link as you have for a non-serverless account, right? So this is pretty straightforward. We don't have much more to talk about it. It's just they're available. And this is the main announcement we did for Ignite. Custom partitioning, it's in preview now. We're probably going GA in the next couple of months. What the hell is this?
Well, I know what it is because I worked with someone that desperately needed this, but I'll let you explain it. It's pretty cool, I think.
Yes. So let's see. So let's start with the same diagram we have in the beginning, explaining what is Synapse Link, right? But how data is partitioned in analytical store? It is partitioned as the data is ingested. The transactional store partition key isn't used. We partition the data just in chunks of data as it is ingested, right? There isn't any particular partition key. And it works very well for most of the customers, but for really big data cases, right? When the data volume is really big, it doesn't work well. We started to see performance issues, right? So what we announced it now. Now customers can use Spark, Synapse Spark, to create a partition store. So now we have transaction store, analytical store, analytical partition store. And the beauty of this is, first, partition store, you can use a column, a property as a partition key, one or more, data, status, state, country, whatever. So
is there a limit to how many?
That's a good question. I don't think so. You can,
yeah.
Find that.
I mean, I'm guessing at some level it gets impractical or you lose the benefit that you're probably seeking out or looking for. So I'm guessing, whatever. Your mileage may vary, but you probably want to test, obviously, against the queries you're running. So
yeah, the secret here is to use a partition key that fits well for your most common used queries, right? So let's say that your analytics, they are reading the data based on the date. So probably date is a good partition key.
Yeah, or date with another one. Like the scenario that often comes to mind for me, and one that was kind of close to the scenario I was dealing with was, I'm a SaaS IoT kind of provider, and I'm tracking lots and lots of devices. But I'm a SaaS, so I'm doing it across many customers. So I've got different tenants, and they all want either real time or near real time updates on how their devices are doing or where they're at. Basically, this was actually tracking vehicles and stuff. And they also want to run big analytics on their stuff so they can do ML and do other stuff so they can get better. And they were ingesting so much data that they had like a GUID for their partition key because they needed to saturate the throughput as efficiently as possible. But that obviously was a terrible partition key or a partition strategy for running any kind of queries. Even once they ingested it into Synapse, still a problem. So here you are, custom partitioning. So now they can partition by date and tenant because that's how the queries their customers are going to run. They only want to see their own data. And then, of course, because it's IoT data, well, it's any operational data, right? It's always the most recent data is the stuff you're going to look at the most. So date also makes another good candidate for there. So
there is more.
Yeah, tell me.
You can create multiple partition stores as much as you need. So let's say you have this very strong requirement to partition the data by date. But let's use your example. Oh, I also need to partition the data by tenant ID. Okay, just create another partition store.
Yep.
So you can have multiple partition stores with multiple partition keys, right? So it's really, really flexible to create and you can create multiple partition stores for your most important queries. Let's say you have this leadership team report that must always be very fast. Okay, just create a partition store just for them, it's really flexible and powerful for our customers.
So how this works is, so I'm going to define this in Spark, basically, right? And I guess you're going to show us.
Yes. I have a demo. I'm going to show exactly how it happens.
Okay.
A couple of benefits. So first one is partition pruning. You're gonna your Synapse runtime will scan less data for each query because you are using the partition key, right? You're skipping you're not touching most of your partitions, right? And this will lead to faster query execution and lower costs. Why lower costs? Because Synapse runtimes, they charge you, they bill you for data scans, for how much data you are reading. If you're reading less data, right, you're gonna have lower costs.
Makes sense.
Yes. And there is also another benefit. It's performance optimization for scenarios when we have for heavy update delete workload scenarios, because we have this new technology that is a updatable columnar format, but it has a price, right? It creates a versioning of your data, and every single query needs to find what is the last version of your data. When you create the partition store, we kind of redo all transactions, and only the last version of your data is represented in partition store. And for the users, from the user perspective, there is no difference. The only difference is it will be way faster, right? So for scenarios where heavy on updates and deletes, it will bring kind of compression benefits, right? Defragmentation.
Yep.
Also, the same defragmentation we have for slow data ingestion scenarios. So let's say you just ingest, I don't know, a few gigabytes per day. You're going to create multiple columnar formats behind the scenes, columnar files behind the scenes. And of course, we have a garbage collector that will compress that files, but it takes time. We don't run it around in real time, right? When you run your partition store, when you create a partition store, again, you are doing this defragmentation of your data. So multiple benefits of custom partitioning.
Now, let me ask, so does this Spark operation, this is, I guess, a job, is that right? Does it run continuously, or does it need to run continuously, or do you schedule it, or what? How does that?
That's a great question. It's custom managed.
Okay.
And I have an answer for that in 2 slides, but it's custom managed. And the beauty is, let's say you have one partition store that you don't need to have the data updated every day. So you can run, don't know, every week. For other scenarios, you need the data updated every 15 minutes. Okay, just run the job every 15 minutes, right? So it's fully customizable.
Got it. So if I'm doing real-time dashboards, I'm likely going to have this thing running constantly or frequently.
Yeah.
And then if I'm doing monthly reports, then just kick the thing off before I run my reports, and then do it that way.
Exactly. So at the end of the day, you see customers running some jobs every 10 minutes, every other jobs once a day, and things like that, right?
Got it.
It's fully flexible. Another important information, when you are reading, since we are talking about the jobs, right? When you are reading the partition store, what happens with the tail of the data? So let's say you're running your job every hour. So we are updating your custom partition store every hour. But what happens with the data that was ingested in the last 59 minutes, right? I won't see this data. No, you see this data. Our connector is smart enough to read all the data that is required from custom partition store and the tail, the delta from the regular analytical store.
Oh, that's cool. Yeah, yeah. Makes sense.
We don't let our customers down.
Got it.
Customers using our connector is really smart, and it will detect and will always show you the whole thing, right?
Now, would it, when you say it reads the tail of the data, does it do any processing on it that was maybe defined with the custom partitioning
No,
as well? It doesn't. Okay.
the tail is read as the regular analytical store is read. Yeah.
But it's not much data, so the queries don't have to work that much harder to process it.
That's an excellent comment. That's not much data. What if it is? Just run the job more often.
Yeah. Oh, okay. Okay.
Right?
Right.
It's a kind of fine tuning between business requirements and performance requirements.
Well, you know what? And this is true with anything in Cosmos that I tell folks. They're like, hey, how long is that going to run, or how much is this going to cost, or whatever. I said, look, you have to run it and measure it to see under load what the performance is going to be. It's hard to predict some of these things. So you just have to put a load on it and then measure, see how it goes. So okay. Exactly. Makes sense.
A couple of limitations. Today we support only Spark 2.4, the connector, right, to create the custom partition store. Only Spark 2.4, but Spark 3 is coming next week.
Oh, okay. Hey, folks, making some news here. Pre-announced. That's good.
Yes. Synapse SQL serverless can't read from custom partition store yet, but probably in a couple of months it will be there as well.
Okay, on the roadmap.
Yeah. And for now, SQL API only. We are working on MongoDB API. Again, we need a couple of months, right? We are working on that. So these are the current limitations. So let's talk about the job itself. We were talking about the job before, right? It's fully custom managed, and customers will define the frequency, how often they're going to run. They can define the path in Azure Data Lake Store. So customers can define a path that is easy to remember, that is familiar for your data scientists, that your data engineers want, right?
So this isn't like the fully managed that you have with Analytical Store. This is customer managed. Is that what I'm hearing? So you're writing this out into your own data lake.
Exactly.
Okay.
So the regular Analytical Store is fully managed. You can even see the data files, the columnar files. Right?
Can I connect to them with my own?
You can't. This one, the custom partition store, yes, you can. You see the files in your storage account.
Okay.
Data will be saved in the same Azure Data Lake storage account of your Synapse workspace. When you create a Synapse workspace, you need to define a Data Lake store account. So that's where we're going to save the partition.
Got it.
Yeah. And again, customers may have multiple jobs with multiple schedules, feeding multiple partition stores that are using multiple keys. So total, very, very, very flexible, right?
Let me ask you this. Fully managed Analytical Store data is replicated in every region. What about this stuff?
That's a good question. If you don't say anything, it will replicate in all regions.
It will.
But you can, of course, specify one but
you have to provision ADLS per region, right?
yes. No, so let me get it back. No, it will replicate. It will create a custom partition store only in the region of your data lake store of your Synapse workspace. Yeah.
So that's where you're running the jobs. Okay.
Yeah.
Okay. So if I want to do custom partitioning, multiple region, define the workspaces per region, run the jobs per region, etc.
Exactly.
And obviously I'll have my ADLS.
Yeah, and that's nice. Let's say here in the US, we want the data partition by date, but the guys there in Japan, they need the data partition by country, something like that, right? Fully flexible. We have this link. We have more information about custom partitioning.
Oh yeah, let me put that up here.
Our AKMS Cosmos DB Synapse Link custom partitioning. It's our blog post with more links and more examples, more details, right?
Yep.
So let's talk about the job. So on the left side, of the slide, that's how we define the job.
You want to zoom in on that a bit so I can. There we go. Okay. So what do you got is
so to define the job, we use a Spark Read command, our OLAP connector. This is Spark, right?
Yeah.
So the first option is always the name of the linked service. That's how you call your Cosmos DB in your Synapse workspace. Then you need to say which container do you want to partition. So it must be a container with analytical store enabled. And here is just to confirm that we are doing custom partitioning. So true. The next option is the key. So you're going to say the name of the property and the data type. And here, if you use semicolons, you can keep on adding more keys. So let's say I want read date, country, state, and whatever. So it'll be just, you will just add more keys to this string here, right? That's where you define the key. Then the base path. The base path is the path you want in your data lake store, right? So here's a example, Cosmos DB partition store, but you can create, I don't know, Mark 2022. It doesn't matter. It's up to you, right? Customers will define the path they want. And from that path, our connector, the jobs will create folders with according to the partition keys, right? So this partition file.true is always required. It works together with the partition true. You don't need to change that. But it's interesting, the max records per file. So the bigger, the better. And we have this default value for 2 million. But again, that's fine tuning. The ideal is to have customers defining, testing, if it works well with a bigger number, a smaller number. So the best practice is to test, right? Usually 2 million is working well for huge data volumes, but you may want to try to avoid files that are way bigger than this or way smaller than this, right? If not, it is what it is, but doesn't matter. But
2 million's, I guess, the median point, I guess, in terms of what we've tested with customers, I guess. And so that's a safe place to start. And I guess you can tweak it from there, kind of, right?
Yes.
Okay.
So we have here the partitioning. Just to double check here a couple of these options. When you said the partition is true, it triggers the job immediately. If you say false, you are going to create the job but not execute it. So you need another command to run it.
Got it.
Keys. So partition keys using DDL format string, read string. I want to add that when we do schema inference, properties, the first level of your document in transactional store, they will be columns. But what else? What if I have a nested object or an array with multiple nested levels of information? You can choose any nested level, any property in any level to be a partition key.
So do I just have the path basically to that property then? So I don't know. Let's just say I have address and then I need zip code. So it could be address/zip code.
Yes.
Okay.
Exactly.
Got it.
The base path we already mentioned. Oh, something important. So let's say we have this job here defined and it's running for a while. And suddenly one day, another data engineer opened his notebook or her notebook and changed the path from Mark 2021 to Mark 2022. What happens? You're just creating another job. It will create another custom partition store, right? So
and write all of that data into it, I guess, right?
To
start over.
Exactly. And the old one will be kept as it was before.
Okay.
Right.
What's the last line in there, the shuffle.partitions?
Shuffle partition. I don't know. I need to double check this one for you guys.
Okay.
Sure. Yeah, this one I forget. I just forgot now. Sorry.
Right.
Let's add the information later to the video description.
Okay.
Okay, I have the job running. I have custom partition on. How do I read this data? Right? So it's almost the same command we have in Spark to read the regular analytical store, the linked service name, the connector, linked service name, the container name, the keys you want to use, so you need to repeat them here. And it may be a different universe from here. So, but you can't skip one. So let's say you defined your partition keys as dates and country. If you just try to read by country, it's skipping the date, it won't work. You're going to do a full scan. You can't skip one. You can skip one in the order, but I can, if I define date and country, okay, to skip country. Okay. The base path, just so exactly the base path you mentioned here. So that's why the base path is important. When you are reading, you need to use what you created here, right?
I got a question from a viewer here. What's the file format for this, for custom store?
Parquet.
Yeah, okay.
Parquet.
Okay.
Parquet files. Very good question. Thank you. And so here you define your read command, but you know that Spark is lazy, right? So you define it here, the path you want to read, the partition key you're going to use, but nothing happens. The data is read is when you populate a data frame, right? And when you execute the command to filter, so here I'm filtering data from this day here specifically. And that's when only the data from this partition is read.
Got it.
Right? That's how it works. So let's do a demo.
Yeah, let's see it in action.
So first, let me go back to the full Fidelity schema thing real quickly. I have here my brand new Cosmos DB database account, right? If I just created. If I go here to Data Explorer, if I click the Enable Synapse Link button, it will use the default. So full fidelity schema for SQL API, it's not here in the portal yet. This button here will use well-defined, and you can change it later. So if you want to use full fidelity schema for your analytical store, for your SQL API accounts, don't enable in the portal for now.
Okay.
What do you need to do? You need to use PowerShell or CLI. So I have a, let's see if I can zoom in this thing here. I don't think so. But this is a PowerShell command, and we have this analytical store schema and full fidelity. And also you need to enable analytical store to true. So that's how it works. And the output of this command will show that your analytical store configuration schema type is full fidelity.
Got it. Okay, so PowerShell or CLI, what you got there?
Yes.
And can just run update on the account, pass in the account, the resource group, of course, and then those properties for the schema type and enable analytical. And also, you have to set TTL too at that there as well, don't you? Or that's at the container level. Sorry.
TTL is container level. Yes.
Got it.
Good point. So here, this is my Synapse workspace, and I have this very small notebook here. So again, that's how we define the job. And that configuration you asked me about, as you can see, it's not mandatory. I think that's why I don't know exactly what it does, because usually I don't use it.
Yeah, I see. It's not even there. Yeah, okay.
I will find out what it is. I'm curious now as well. I didn't realize the difference. So we have here in this container something like a terabyte of data. And it's a tiny document. So that means a lot of rows, a lot of documents, right? And if we use the regular Synapse read operation, and I'm not reading from custom partition, right? This query took 2 minutes, 1 second. 2 minutes. The same query, same results, by the way, right? Of course. But now reading from partition store, 31 seconds.
Yeah, okay. So order of magnitude better for that query.
Yeah, in this case, that's not that huge, right? 1 terabyte of data. We have a very good performance. It's 4 times faster.
Yeah.
Right. So basically, that's how it works, and that's the level of benefit of custom partitioning, right?
Yeah. So good for definitely your high concurrency queries. Or
yeah, exactly.
Makes sense, right? Because you're going to run that once and then get the benefit on all the queries executions that you run on it.
Exactly. Yes. Yeah. And so let's talk about the roadmap now. Oh, let me switch this thing. Let me swap. So roadmap, I can say that very near roadmap. We have existing containers, Power BI integration. If you're curious, you're probably exploring Azure Portal. You probably saw some news about these 2 items here. We will be able to talk about them in a couple of days or weeks. Also, the capability to turn analytical store off is coming as well. And that's important because for two aspects, for 2 customer requirements. The first one, let's say you turn it on and you didn't like it, you don't want it anymore, or maybe you were using 1 container and that container is not being used anymore. So it's hard because the only way to get rid of it was to delete the container.
Yeah.
Customers will be able to turn it off.
So when that turns it off, it actually deletes the underlying Parquet files that are created. Okay.
But there is another key aspect here. The first document of the collection defines, in well-defined, right? That is a default option for SQL API. The first document of the collection defines the schema. What if the first document has a problem? It was a test, and customers want to reset the schema. There is only one way to do it. It will be to turn it off, delete the document that is bugging your schema, turn it on again. So,
Well, that sounds good because you're not paying to hydrate the analytical store anyway. So we would do that for you. So yeah. And I guess it would take as long as it takes for depending on how much data you got. So
yeah, it sounds like something not that important, but it is important. Also, Peter, point-in-time restore integration. So today, customers can't use point-in-time restore and analytical store Synapse Link in the same account. Coexistence in the same account is coming with the capability. Customers will be able to back up and restore analytical store.
Oh, okay.
Yeah, that's really, really powerful, a very common ask we have. Also, we are working on benchmarks, TCO analysis, and of course, existing containers for MongoDB API. And I want to close with our official labs. We have these other AKA MS.
Yeah, I put that up earlier as well and left it up there while people were.
It's a GitHub repo. We have 3 examples. One using cognitive services for anomaly detection, the other one using Azure ML SDK for forecasting, and the third one using MongoDB, just a full Fidelity schema.
Okay.
Example.
And they're notebooks, basically, right? They can just...
Notebooks, yes.
Okay. So they can download those and upload them into their workspace if they want.
Exactly.
All right.
And this is my email address. Please, anyone with questions, please let me know. Just ping me. I'll be glad to help.
Well, that's great. Good luck to your inbox. Probably going to get brutalized after this episode, but okay.
No
it's you, not me. So.
No problem.
That's good. That's good. Well, this is fantastic, Rodrigo. Definitely long overdue having you on talk about Synapse. I mean, we've had Synapse Link for what, 2 years now? I guess almost 2 years. Is it? Or
almost 2 years.
Yeah,
it'll be 2 years in May.
That's right. That's right. We announced it at Build, didn't we? Pre-announced, yes. Actually, I think it was more like we pre-announced it's coming, and then I think by Ignite we got around to it. So yeah, that's awesome. It's amazing the work the team is doing around this. It just gets better and better, and you can tell, obviously, listening to what customers are telling us with things like custom partitioning, with things like full fidelity, with things like being able to turn it off if they want. Those are all customer asks, if I'm not mistaken.
Yes.
So great stuff. Well, thanks, Rodrigo, for joining us this week, and thank you, everyone, for joining us. Next week, I've got Tim Sanders coming back. He's a frequent flyer on the show. He's going to talk about indexing metrics, which it was another thing we announced at Ignite back in November. So pretty cool episode. He's going to show you how you can get smart on your queries by looking at the indexing metrics in there. That'll show you what indexes your queries are using or what indexes it could be using to make them even better. So come back and he'll show you that. Also, we've got our Azure Cosmos DB Global User Group, another meetup coming next Wednesday. We've got Hassan Sabrin, who's going to talk about how to tune performance for your Azure Cosmos DB databases. So come and join us. That'll be Wednesday, 1 p.m. Pacific. That's, I guess, 4 p.m. Eastern, about 9 p.m. London time. I don't know what that would be for Sydney. I can't do the math that well. It's too many hours to count, but it should be morning sometime for you there. So come join us for that. And yeah, that's it. Oh, I guess also, if you've missed any episodes, please feel free to go and watch on demand. We've got, well, now 36 episodes in the can here. So lots of content. You can, in fact, go back and see Rodrigo's episode on Python SDK, which, hey, Rodrigo, I don't know if I ever told you this, but it's actually one of the most popular episodes.
Yes.
It's shocking. People love you, man.
I was lucky, man.
I'm hoping I get a huge bump from this show too. I mean, I don't know. Something about you. So. All right, my friend. Thank you again for joining us. And thank you, everyone, for joining us. We'll see you again next week.
Thank you so much.
Yep. Bye-bye.
Bye-bye.